This week, we're bringing artificial intelligence to life as we teach computers to walk, talk, and see. Prepare for the rise of the machines. Last week, we got up close and personal with artificial intelligence. We met quiz champion Watson, who's now turning his hand to company acquisitions and cooking. And we saw how AI can learn to be better than us at writing computer code, coaching sports, and working towards treating cancer. This week, we're going to go one better. We are going to build an artificial intelligence. And to do that, we need three things: a really silly costume, Click's resident computer boffin Stephen Beckett, hello. Hello. And a massive laboratory. It's good, isn't it? Photorealistic, stunningly rendered, and almost finished. They'll be fixing that next Wednesday. Anyway, Stephen has been building an artificial intelligence, and you've been training it to learn how to walk. That's right, yeah?
Yeah, sort of like walking. Well, come and have a look. It's probably easy to show you on the computer. So this is a game called QWOP, so called because it uses letters Q, W, O and P to control the character.
Right.
The aim of the game is to run along this race course just using those letters to control its legs. It's actually very, very difficult to control him.
Extremely difficult, especially on a completely imaginary computer. Yeah, okay, I'm rubbish.
Yeah, you're rubbish. It's very difficult, so keep on falling over.
Okay,
yeah.
good. Now, Stephen has used, correct me if I'm wrong, a type of artificial intelligence called a neural network.
Yes.
This is where the real science starts, so get ready. Steve, hit us.
Right, well, you can think of neural networks as very simplified models of our own brains. We've got billions of neurons which let us do all sorts of amazing things, like speaking, dancing, and, well, programming neural networks.
All very meta.
Thank you. Computerized neural networks are much, much simpler, of course. We're talking dozens of neurons rather than billions. Just like us, though, it needs a signal to work with. And where we have eyes, it has data.
Yeah, we're going to give it just a few bits of information. Things like the angle of QWOP man's body parts. This is how our neural network sees the world.
At the other end of the network, there are 4 output neurons, one for each of the 4 letters that control our QWOP man. If one of these neurons fires, the corresponding key is pressed, and the appropriate body part moves.
And in the middle? Well, that's where the magic happens. It'll start as a very simple network of neurons sending and combining signals. But by the end, boy, will it be a lot more complicated.
The more complex the network gets, the better it should be at playing QWOP. This is the learning process, and it starts as trial and error, kind of like how we learn as kids.
So that's the basics.
The basic, excellent.
Yeah.
Okay, well, I look forward to the detail later. And just to say, the set may be stupid, the experiment may seem silly, but this is real computer science we're doing here, right? Fire it up. Is that entirely necessary?
Yeah, I think it was actually. I think it adds something. Yeah.
Right, so there's a lot of horizontal stuff going on.
I think he'll spend quite a lot of time just falling over.
Right, okay, will he ever get up?
I think if we leave it running for a while,
maybe it will run.
yeah, fingers crossed.
Good luck. Learning to walk is one of many life skills an AI has to learn before it can have its dastardly way with us. And while QWOP man attempts to stand, I thought I'd take a trip to Oxford University to meet the researchers looking at another aspect of understanding the world around us: sight. Human senses work rapidly and in complete harmony to perceive the world around us, and our brains have incredible capacities to easily interpret this deluge of information. Computers find this task incredibly hard because the real world is not easily represented by pure data. Researchers are working on computer vision, so one day robots can do the same. For it to be successful, the computer needs to be able to distinguish items in a scene, identify what it's looking at, and develop an understanding of its circumstances so it can complete its task. The researchers are working on a neural network that can identify 20 objects at a time. Now, that doesn't sound like many, but if they get this right, then they can apply the same method to millions of objects. The network is fed manually separated images. As it scans the features of an object, it develops and tweaks its understanding. It learns from its mistakes and gets better at recognizing other instances. Most importantly, it gets more efficient at it every time. But for it to be of any use, it needs to get it right as often as humans do, and very quickly, no matter how tricky the scene. The greatest minds from the world's leading AI research centres are all working on this problem. But even with only 20 items to recognise, the best software around can only get it right 3/4 of the time. This is where some human help might come in handy. Here's a room with some objects in, and I'm using a 3D infrared camera to scan my surroundings. Now I'm going to hand the camera to Stuart while I label the scene, and you do that like this. As I go around touching the items, I'm quickly identifying the different classes of objects in my environment. So one day we may all be able to help our machines to recognize our stuff, no matter how unique it is. But the world we live in doesn't stay still. So another team of researchers here in Oxford are working on applying the same principle to moving scenes, segmenting objects from their background on the fly. Which is exactly what these prototype augmented reality glasses are doing. They're made for partially sighted wearers, and they use the same dynamic algorithm to highlight things of interest. Yeah, this is really effective actually. I can understand how if you have impaired vision, this would really help you to navigate around. Things that are closer to you appear brighter, those that are further away are darker. And all the edges are really emphasised, so you really can work out which objects you might want to avoid.
What we want to do is produce these augmented reality glasses that will help partially sighted people see. So I think that's a really good waypoint in order for us to test the algorithms, see how well they work. I think vision itself will be really useful for navigation, understanding the world, completing tasks. So I think all of those things are key. Actually, having perception is key to making a robot successful.
Away from the lab, it was the week that Apple had to remove some of its apps from the App Store in China. The apps had been created by developers using counterfeit software. Unbeknown to them, the apps were infected with a malware that enabled hackers to secretly steal data about users. If you've ever felt like shouting, "Get out the road" to hazardous selfie takers, well do, because this week we found out that more people are killed taking selfies than by sharks. Brain-to-computer technology has helped a paralysed man walk. This is the first time it's been done without the use of robotics. The brain controls the legs directly through electrodes. Facebook has announced it's now rolling out 360-degree video in timelines for a more immersive experience. A range of publishers have signed up, with content including an exclusive 360 experience from the upcoming movie Star Wars: The Force Awakens. And finally, have you ever thought about using your hair to send a text message? Yes, you have. Check out these new smart hair extensions. They detect touch and then use machine learning algorithms to recognise a user's intention. You can even record conversations without being noticed. Or I can message my mum whilst presenting the news.
Back in the lab, the neural network behind our QWatt man has been trying different keystrokes for quite a while. Most attempts have ended in an immediate faceplant. But then, this happened. It achieved a step. The shuffling began.
Very cool. I'm a proud parent. Baby's taking his first step.
There he goes.
So I think now's a brilliant time to take a look inside. How is the neural network doing that?
Well, we can dive inside of its brain.
Oh, crikey, we have.
Yeah, so the brain of our AI is actually changing over time. In effect, it's rewiring itself in different ways to try and get better at moving our Kiwat man. It does this using another idea pinched from nature: evolution. If we go back through the vast eons of time to the start of the show, we can take a look at the Quap primordial soup. Inside this soup are hundreds of randomly generated neural networks, all of them very, very simple. One by one, each of these networks is given a go at controlling Quapman. Most of them will be pretty rubbish at this, hence all the falling over, but a few, essentially thanks to blind luck, will be a little bit better. And those ones, the ones that get the furthest, fastest, are eventually given the chance to reproduce with other high-achieving Quap brains. Over time, by breeding the best of each generation, and also throwing in a few random mutations along the way, we get networks that are more complex, and crucially, much better at playing Quap.
Now, there are many different ways of moving about on two legs, but there are no guarantees that our neural network will settle on that good old left-right thing. In fact, Kiwat Man seems to have settled on this kind of shuffle, and this is the method it's now refining.
I mean, that really is brilliant. Incredibly slow, painfully slow, I have to say.
Yeah, I wouldn't want to watch it do the whole race at that speed.
No, true.
So the only way to make it go faster is to just leave it running for longer, maybe tinker with a few settings.
Okay,
So
tinker
I'm gonna
away.
tinker away.
Okay.
Yeah, we really should have bought a real keyboard. Still, as we've been seeing over the last 2 weeks, AI has been creeping into many areas of life. I say creeping because it is often thought to be, well, creepy, to have bad as well as good effects. As AI gets better, for instance, will it one day take our jobs? Over in San Francisco, one startup has begun using an AI system which is already doing the job of dozens of humans. We Heart It is an image-sharing social media site aimed at young women, a bit like Pinterest crossed with Instagram. Thousands of images are shared, liked or hearted through the site each day, and each one has to be checked to make sure it's suitable. No small task for this tiny team.
We've got about 28 employees. Our user base for the site is 35 million people. We serve billions of images every day that users view. We have hundreds of thousands of new images coming in every day, and it's not possible manually to maintain and moderate this, this big site.
To overcome the scale of the problem, the startup brought in AI specialists Wise, who built them, in effect, a personalised AI spam filter. Over several weeks, the system was shown the way past images were treated and learned how to do the same. By analysing things like the pixels in the image and metadata about what was posted and who posted it, the AI can figure out exactly what spam means for We Heart It, which might not be spam for anyone else.
Let's say that your father is a traveling salesman who goes to Nigeria very often, and he happens to sell Viagra, and he just won the lottery. He would send you an email and tell you how excited he is. For most people, that would be considered spam, right? Those sort of hit all the high points of what spam is from an email perspective. But for an individual where you have a spam filter which is essentially highly tailored to you and knows something about your past interactions with your father, let's say, that's sort of the destiny of where AI is going, and that's the kind of thing that Wise is trying to do.
The We Heart It system also learns over time, so if a user sees something that slipped through the net, they can flag it as inappropriate, and the AI will be more likely to catch stuff like it next time. Now the system sorts through the hundreds of thousands of pictures each day, flagging just a few dozen as probable spam. This is all about making businesses more efficient, both in terms of how much cash they can make from customers, but also by making the most of the people they have. So, is this evidence that AI will threaten jobs? Well, although this small startup would never have existed in the first place if it relied on human labour, opinion is divided as to what the impact will be on the world's workforce.
Some people think about machines as taking us and our jobs away, and we're just going to be able to write poetry all the time. And in a sense, the world can't afford that much bad poetry. Right? We're not all going to be good at those sorts of things. Neither are machines. But yet, using the machine, partnering with it, collaborating with it, that ambient intelligence sense is really going to be important. Having it around us and helping us is nice. Having it control our lives isn't so nice. I don't envision that happening.
That's not, however, the opinion of this man. I went to meet him in his offices overlooking New York Harbour, where he let me in on his plans for world domination. A lot of people are worried that artificial intelligence will put people out of work. What's your take on that?
Well, I asked them, what happened to the horse and carriage driver? What happened to the bank tellers? The bank tellers are gone. Most of that has been replaced with an ATM. Well, they have moved on to become financial advisors. And we are continuing to evolve our human brain. And technology will make man move to these more intelligent forms of expression, creative forms of expression.
So artificial intelligence may force us to evolve in order to survive, or otherwise, by enlarging the creative side of our brain.
Absolutely.
It's big talk, but Chetan Dubey has a reason. His invention is called Amelia. She's the result of 17 years of research by this computer scientist, and she's one of the most convincing AIs I've seen to date. One that seems to understand English and be able to have a meaningful conversation.
So, Benjamin, you want me to help you reset your SAP password?
Ignore the fact that we're typing the responses and ignore the face and the voice. What Amelia does with the words she reads is what's really impressive here.
So that's Amelia's brain. That's correct. That is a snapshot of her neural ontology. What it is equivalent to is taking a snapshot in my head and seeing what do I understand, what concepts are related to each other.
Amelia is currently being tested by several companies to replace online call centre operators. Here, we're asking her to assess me for home insurance.
I need to ask about the major operating systems of the home, such as electrical, heating and plumbing, and the ages of each. Thanks for the information. When was the home built?
Tell her about yourself and she'll pull out the important facts from the text and work out which questions she now doesn't need to ask you. And that's more of a human conversation than I've had with some humans. Here you can see her adding the facts to her knowledge graph, in this case facts about me. But her creator insists she could do this with any text that she's given.
If she picks up an article from BBC about the English cricket team managing to beat the Australians, she should become very conversant in reading that. She should be able to read and expand her knowledge just on the fly, not taking years of saying I'm going to try and now start to build data models, and then I will actually build a search capability to be able to query that data model. Just like a human, she should be able to read and say, oh, okay, hey.
Can Amelia do that?
Absolutely. Absolutely.
Chris bought a car from me yesterday.
Good to know. Ergen.
Who owns that car?
Chris.
And that's not all. Amelia's apparent understanding of English means that this is how she learns her job too. It's a flowchart written in English. That's it. This is a description of how to be an insurance agent. It's written in English, and there are decisions to be made and arrows going to various parts of the chart. A human can understand this, and this is all that Amelia needs to understand how to do her job too. And here's the even more impressive part. If the customer says something that isn't in her job description, if there's no option in her current flowchart, she calls in a human operator, she watches, and she learns. Amelia has added what she's seen to her process tree. She's added it to her job description in English.
We should only call someone smart if they can represent the smarts of a simple 10-year-old. Can they read an operating procedure? Can they solve a problem for me? And if they are not able to, let's say, are they able to learn from observing what did the human agent that knew how to respond to that question, what did they do?
I get the feeling that although Amelia works very convincingly in limited environments like following a flowchart, expanding her into an all-encompassing general AI will be an exponentially massive task. But maybe the solution instead will be several smaller, more specialised AIs, each talking through and learning about different aspects of the world around them.
Eli, grab the white thing.
Do you mean this one?
No, the other one.
This is Eli, and although he doesn't understand insurance like Amelia, he can learn how to interact with physical objects.
Eli, poke the thing in the middle.
I don't know how to poke something.
Eli, point at it. Eli, extend your hand. Eli, retract your hand. Eli, that is how you poke something.
Okay, now I know how to poke something.
Eli, poke the red object.
So, we've discovered AIs that can see, that can talk, and that can pick things up. And our AI, QWOP Man, is learning how to walk. We're definitely getting closer to that all-powerful machine. If only Steve could keep it upright. But then, in a moment of realization, he cracks it.
What are you doing?
Well, I've just been making a few changes to the system, and I think I've had a breakthrough.
Okay.
So basically, all the previous generations were having lots of problems staying upright because they really had no concept of where the top of their bodies were, where their torso was.
So they were overbalancing?
Yeah, exactly.
Without knowing.
They didn't even know they had a torso until just now. This one here has figured out that if you go a little bit too far backwards, then you need to stop pressing Q, because if you do that, you're going to fall over.
I mean, it is like an evolutionary leap, isn't it?
In QWOP terms, this is the missing link.
Okay, show me.
Okay, you ready?
Yep. Oh, right. You couldn't have used this enormous monitor earlier.
No, I was saving it for dramatic effect.
So he's actually going faster.
Yeah, it's like a record pace for a QWOP champion. This is the fastest I've ever seen. It's not blindingly fast, I will admit, but if you compare it to some of the earlier ones we saw, that's pretty sensationally fast.
Virtual high five? There we go. Do that in post afterwards. Yeah. And there's the 100 metres. Yeah. I have never seen this part of the game before. Come on.
Come on, little QWOP.
Come on.
Come on, Quappy.
Yes, finally, it happened. QWOP Man had not only shuffled and shimmied, but he'd made it across the finish line.
QWOP! Great. That was totally worth every bit of the castle, building, everything. It was.
I think so. Don't worry, we'll open it to tours in a few years' time. We'll work for Harry Potter. I think that's quite impressive.
I think it's gone quite well.
We've kind of almost made a man
kind of walk.
And I hope it's giving you an insight into how a neural network might work. Thank you, Steve. Pack up the computer. Thank you very much for your time.
Don't press the button, by the way.
What, the big button?
Yeah, don't press it.
No worries. All right, thank you very much for watching, and we will see you next time.